Deep within the heart of these limestone mountains lies a facility where nature's raw elements are transformed into the world's most precise optical masterpieces today. This is the birthplace of clarity. A place where the ancient earth meets modern engineering to redefine how we perceive the light of the entire world. It all begins with this humble material, quartz sand. Refined to a staggering 99.9% purity. The foundation of every high-end crystal lens produced. Each tiny grain holds the potential for absolute transparency, waiting to be reborn through fire and precision into a window for the most advanced technologies. The journey starts on the assembly line, where massive quantities of raw minerals are fed into the system to begin their long and complex physical transformation. Precision begins at the very first stage. As the sand is carefully measured and directed into specialized filtration units to remove any trace of natural impurities, high-frequency vibration screens sift through the material, discarding every dark stone and foreign particle to ensure only the most uniform white crystals remain for processing. With the impurities gone, the sand is now a blank canvas, ready to face the intense heat that will forever change its molecular structure and appearance. The raw quartz is packed into specialized ceramic crucibles, designed to withstand the astronomical temperatures required to break the bonds of the solid crystal structure. As the furnace doors lock tight, the environment inside becomes a crucible of creation, where the laws of physics will bend the very nature of stone. The air thickens with heat as the power surges, pushing the internal temperature toward a level that rivals the molten core of our very own planet, at 1700 degrees Celsius. The solid quartz begins its dramatic surrender to the flame, glowing with a fierce light that signals the onset of melting. Bubbles of air escape the transforming mass as the solid grains liquefy, merging together into a single, cohesive ocean of molten glass that flows like honey. The transition is complete. What was once opaque sand is now a radiant, translucent liquid, stripped of its crystalline form to become something much more versatile. Carefully controlled, the liquid fire is poured into molds, flowing with a mesmerizing grace that belies the dangerous intensity of its incredible heat and energy. Each mold defines the future shape of the lens, capturing the liquid light in a vessel that will guide its cooling process and final structural integrity. Precision robotics handle the searing weight of the glass, moving the freshly cast forms with a steady hand that no human could ever hope to replicate. As the surface meets the air, a delicate dance of thermal management begins, ensuring the glass does not shatter from the shock of its new environment. The factory floor glows with the light of 100 miniature suns, each one a potential lens waiting for the slow, methodical process of controlled cooling. Gradually, the liquid turns back to solid, but it is forever changed, now possessing a clarity that was hidden inside the sand for millions of years. The journey enters a phase of silence and patience as the glass blocks are placed into the annealing chamber for a slow and vital temperature reduction. Controlled cooling is essential. Any sudden change in temperature could create internal fractures that would ruin the optical performance of the final glass lens product. Inside the darkness of the chamber, the atoms of the quartz glass settle into a stable, tension-free matrix, ensuring long-term durability and perfect light transmission. Before moving forward, every block must prove its worth, as high-powered lasers probe the depths of the glass to identify any microscopic imperfections or hidden bubbles. The internal stress manifests as a spectrum of colors, a hidden map that tells the engineers if the annealing process was successful in creating total stability. Human expertise remains vital, as experienced eyes look for the subtle nuances of light that machines might miss, ensuring only the finest glass proceeds to cutting. The blocks are sorted and prepared, each one destined to become a specific type of lens. From microscopic camera optics to massive telescope mirror glass components, with the foundation solid and tested, it is time to move from the world of heat and fire to the realm of extreme mechanical precision cutting. The atmosphere shifts to one of cold, industrial efficiency as the glass enters the shaping phase, where diamond-tipped tools will sculpt its final, functional form. Today, Diamonds are the only tools hard enough to master quartz. As spinning blades bite into the glass to slice it into individual lens blanks with extreme accuracy, disc by disc, the cylinders are reduced to blanks, the fundamental units of the lens-making process. Each one perfectly flat and uniform in its thickness. A constant flood of coolant prevents the glass from overheating, washing away the fine debris and protecting the integrity of the freshly cut surfaces from heat. The blanks are transported with care, handled by suction and soft grips to prevent any scratching as they transition from the cutting stage to the grinding. Now, the mathematics of light take physical shape as specialized heads grind the glass, creating the precise curves necessary to bend and focus light rays accurately. The excess glass is ground away into a fine powder, turning the clear water into a milky stream that carries away the remnants of the shaping process. This removal of material is a work of subtractive art, where the perfect lens is slowly revealed from within the solid mass of the original glass blank. We move into the world of the microscopic, where tools adjusted to the nanometer level refine the surface to a degree of smoothness that defies the eye. Every microscopic scratch is systematically erased, ensuring that when light eventually passes through this lens, it will do so without the slightest hint of distortion. Massive rows of automated workstations work in perfect harmony, scaling the precision of handcrafted optics to meet the global demand for high-quality glass imaging products. Lasers map the surface in real time, providing digital feedback to the machines to ensure the curvature is accurate to within a fraction of a single hair. The human touch remains the final arbiter of quality, as technicians inspect the rough ground lenses for any structural defects before they move on to the polishing. Though still slightly frosted from the grinding, the lens already shows the promise of its future clarity, standing as a testament to the power of precision. The magic happens in the polishing stage, where the dull, frosted surface of the ground glass is buffed with cerium oxide to achieve a mirror-like shine. Hour after hour, the soft pads work their way across the glass, removing the final layers of friction and bringing the quartz back to absolute transparency. The lens reaches a state of near invisibility, a paradoxical object that is physically present yet completely clear, allowing light to pass through without any interference. Rinsed with deionized water, the last remnants of the polishing compound are washed away, leaving the lens in a state of pristine, untouched surgical-grade cleanliness. Today, ultrasonic waves create millions of microscopic bubbles that reach into every corner of the lens, ensuring that not a single speck of dust remains on surface. The perfectly smooth surface naturally repels water, a sign that the polishing has reached the atomic level of perfection required for the highest quality optical systems. Dried by ionized air, the lens is now a masterpiece of clarity, ready for the final and most high-tech stage of its long manufacturing journey. Here, the lenses are mounted into carousels, prepared to enter an environment where they will be shielded with advanced chemical layers to enhance their performance in light. The vacuum chamber recreates the void of space, a necessary condition for the delicate process of vapor deposition that will give the lens its final powers. Plasma energy vaporizes rare earth minerals, which then drift onto the lens surface in layers only a few atoms thick, creating a revolutionary anti-reflective barrier today. This coating is what allows modern lenses to capture clear images even when facing direct sunlight, preventing ghosting and flares that would otherwise ruin the shot. Multiple layers are applied, each tuned to a specific wavelength of light, transforming the simple glass into a sophisticated filter of high-performance light management and transmission. Precision is monitored to the extreme, as sensors ensure that the chemical layers are applied with a consistency that is uniform across the entire surface area. As they emerge from the chamber, the lenses have taken on a new identity, glowing with a professional finish that marks them as elite optical components. Now, the transformation is complete, the sand has been reborn as a crystal lens. A perfect marriage of natural materials and the pinnacle of human industrial achievement. In the final test of purity, a laser passes through the glass as if nothing were there, proving that the internal structure is perfectly clear and flawlessly uniform. Every photon is accounted for, ensuring that when this lens is used in the field, it will deliver the most accurate representation of reality possible for users. The lens is integrated into its final home. Whether it be a professional cinema camera or a scientific instrument designed to peer into the farthest reaches of space, through this glass, the world is seen with a clarity that exceeds the human eye, capturing every detail and color with a fidelity that is truly breathtaking. The soul of the light is captured, the culmination of thousands of steps and centuries of knowledge, all contained within a single piece of perfected quartz glass. From the dust of the earth to the height of technology, the journey of the quartz is a testament to our endless quest for perfection and clear vision. Experience the world through the lens of perfection. This is the rebirth of quartz, where the elements of nature become the tools of the future vision.